Hello, in our session today we are going to solve exercise number 34 in the booklet under that exercise. Exercise number 1 we have k, number 34, k is a function with k of x equal exponential of minus x plus 2x. Part 1, limit as x tends minus infinity of f of x, we just replace x by minus infinity. Limit as x tends minus infinity of f of x equal exponential of minus infinity is plus infinity. 2 times minus infinity is minus infinity. Plus infinity minus infinity if. We said before that when we have plus infinity minus infinity, we should factorize. So we are going to take x as a common factor, and in fact here we can take x as a common factor or as also e minus x as a common factor. I'm gonna take e minus x. Limit as x tends minus infinity, e minus x common factor will have 1 plus 2x divided by e minus x. E minus x divided by e minus x is 1, 2x divided by e minus x, 2x over e minus x, equal limit as x tends minus infinity, e minus x into 1 plus e minus x we can get it up to the numerator, so it's 2x ex and change the exponent. As minus and over minus infinity, we know that limit of x ex over minus infinity is 0. It's a formula in the recipe. So equal exponential of minus infinity plus infinity into 1 plus 0, 1 equal plus infinity. If you try to take x as a common factor, it will work also. Then limit as x tends plus infinity of f of x equal exponential of minus infinity is 0 plus 2 into plus infinity equal plus infinity. So at minus infinity is plus infinity and at plus infinity is plus infinity. Part 2, study the variation of k. It means we have to calculate k prime of x and study its sign. Derivative of e minus x is minus e minus x. Derivative of 2x is 2. So we have to find its root and study its sign. E minus x plus 2 equal to 0. It means e minus x equal minus 2. E minus x equal 2. Minus x equal ln 2. We use ln on both sides to cancel the e. So x equal minus ln 2. So minus ln 2 is the root of k prime. X vary according it's defined over R, so it's vary from minus infinity till plus infinity. K prime admits minus ln 2 as a root, and we have to sign it the variations of k. According to the sign of k prime vanishes at minus ln 2. Minus times minus plus, and minus plus. If you try it here like 0, you will obtain 1. So it's positive here. So it's decreasing, increasing at minus infinity, it's plus infinity, at plus infinity. And you need to calculate f of k of minus ln 2. You just replace x by minus ln 2. And the answer will be 2 minus 2 ln 2. Okay, 2 minus 2 ln 2. Deduce that for all values of x that e minus x plus 2x is greater than 0. So we have to deduce that k is greater than 0 for any value of x. I will calculate 2 minus 2 ln 2. 2 minus 2 ln 2 is 0.63. It's 0.63. So k of x is for sure greater or equal to minimum, and the minimum is 0.63, which is greater than 0. K of x is for sure greater or equal than the minimum, which is 0.63, which is greater than 0. So by transitivity, k of x is greater than 0. So it's always positive. And I think that we will use the sign of k of x in another function. Part 2, consider the function f defined over R by f of x equal ex minus e minus x minus 2x and designate by C its representative curve. Part 1a. Let's just clear the page. So do not forget that we showed that k of x is positive, okay? So we have in part B f of x equal ex minus e minus x minus 2x. Show that f is odd. To show that a function is odd or even, to study the parity, we have to calculate f minus x. If the answer is f of x, it's even. If the answer is minus f of x, it's odd. So we just replace x by minus x, e minus x minus e minus x minus 2 into minus x equal e minus x minus e x minus 2x. This is f of minus x. It's not equal to f of x, so it's not even. I will try to calculate minus f of x. Minus f of x is minus ex plus e minus x plus 2x. Okay, this is plus. I got the same answer, so f of minus x equal minus f of x, so f is odd. And when a function is odd, in this case, you know that the origin O is the center of symmetry of the curve. Part B. Calculate limit as x tends minus infinity of f of x. We just replace x by minus infinity in the function. Exponential of minus infinity is 0 minus exponential of minus infinity plus infinity minus 2 into minus infinity equal minus infinity plus infinity if. So we have to factorize, right? I will factorize these both terms only because of those two terms I got if. So limit as x tends minus infinity of f of x equal limit as x tends minus infinity ex minus, I'm gonna take e minus x common factor, e minus x divided by e minus x is 1, minus minus plus 2x divided by e minus x is 2x over e minus x is 2x e minus x. So equal e power minus infinity is 0, e power minus infinity plus infinity, and there is a minus is minus. You know that as x tends plus infinity, this is plus x, okay? As x tends minus infinity, x tends to 0. So it's 1 plus 0, it's 1 equal minus infinity. Then limit as x tends, limit was at plus infinity, e power plus infinity. I have to change it all. I started with this line. I will keep it. هيدا كان limit as x tends to minus infinity. Okay? So this is the solution of this part. Okay? And then limit as x tends minus infinity f of x over x. Limit as x tends minus infinity f of x over x equal limit as x tends minus infinity ex minus e minus x minus 2x over x. we'll get infinity over infinity if. So I'm gonna use orbital rule. Limit as x tends minus infinity. Derivative of ex. Derivative of e minus x is minus e minus x, and we have minus outside, so plus e minus x. Derivative of minus 2x is minus 2 over 1. Equal at minus infinity, this is 0, and this is plus infinity minus 2 over 1 equal plus infinity. So at minus infinity we have a vertical asymptotic direction. Now I will calculate limit as x tends plus infinity, okay? Limit as x tends plus infinity of f of x equal e power plus infinity minus e power minus infinity is 0 minus 2 times plus infinity is minus infinity equal plus infinity minus infinity if. So I'm going to factorize. Okay, let me erase the board firstly. So now I'm going to calculate limit as x tends plus infinity. No, I'm going to calculate limit as x tends plus infinity. Limit as x tends to plus infinity of f of x, we got plus infinity minus infinity if. So we can take x or ex as a common factor. I'm gonna take ex for these two terms, because these two terms that make the result plus infinity minus infinity. Limit as x tends plus infinity, ex common factor ex divided by ex is 1. 2x divided by x, 2x over ex is 2x e minus x. I'm gonna keep e minus x outside. So at plus infinity, this quantity or this identity equal to 0. It's a formula in that chapter. E power plus infinity into 1 minus e power minus infinity is 0. Exponential of minus infinity is 0, and the answer is plus infinity. Then limit as x tends plus infinity f of x over x equal limit as x tends plus infinity f of x is ex minus e minus x minus 2x over x. I'm gonna have infinity over infinity if. So I will use orbital rule. Limit as x tends plus infinity ex plus e minus x minus 2 over 1 equal plus infinity plus 0 minus 2 over 1 equal plus infinity. So at plus infinity we have vertical asymptotic direction. So we have vertical asymptotic direction at minus infinity at plus infinity. Part C, show that f prime equal this much. F prime of x equal derivative of ex is ex. Derivative of minus e minus x is plus e minus x. Derivative of minus 2 is minus 2. But he needs the answer in this form. But don't answer e minus x. He said show that f prime of x equal e minus x into ex minus 1 square. I can take this identity and expand it. Okay, ex square is e2x minus 2ex plus 1 square, a square minus 2ab plus b square. E minus x times ex we add the exponent is ex, e minus x into minus 2 ex e power 0 plus e minus x equal ex plus e minus x, and e power 0 is 1 times minus 2 is minus 2. We got the same answer, so equal e minus x into ex minus 1 square. And this is the easiest way. This is the easiest way. There are other ways like factorizing and things, but expanding in this case is the easiest way. For D, set up the table of variation of f. We have to study the sign of f prime. As you know that e minus x is always positive, and e minus x squared plus 1 is positive, but we can take that ex minus 1 could be equal to 0, ex could be equal to 1, ln and ln x equal ln of 1 equal to 0. It's always positive, but not strictly positive. It could be 0. X vary from minus infinity till plus infinity. E minus x is always positive, so I'm not going to use it. F prime takes the same sign as ex minus 1 square. That admits 0 as a root, but it's also always positive. And f prime, as we said, is always positive, but vanishes at 0. And f is always increasing. At minus infinity, the limit I think is minus infinity. We have a vertical asymptotic direction. At as plus infinity is plus infinity, and we also have a vertical asymptotic direction. This is the first part of the chapter. I will take the second part. This is the second part of the chapter. Okay. Let's just erase some things. I will keep the table of variation because I will use it in drawing the curve or anything else. So this is the rest of the chapter. Show that this curve C admits an inflection point. To find the inflection point, we have to calculate R2. Okay, we have to calculate fw prime of x, the derivative of f prime. Derivative of ex is ex, and derivative of e minus x is minus e minus x. Derivative of minus 2 is equal to 0. Equal ex minus 1 over ex. Common denominator ex equal e2x minus 1 over ex. As you know, ex is always positive. We have to study the sign of the numerator. E2x minus 1 equal to 0. E2x equal 1. Ln and ln 2x equal ln of 1 0, so x equal to 0. So fw prime x vary from minus infinity to plus infinity. Fw prime admits 0 as a root opposite, and same. So here is concave up downward, and here is concave upward at x equals 0. Fw prime of 0 equal to 0, and fw prime change its sign. So we have an inflection point. I'm gonna call it Z, inflection point of abscissa 0, and ordinate f of 0. F of 0 is مش هيدا 32 يمكن f of 0 equal exponential of 0 1 minus exponential of 0 1 okay 0, so 0 0 is the inflection point. Okay. Part 3. The adjacent figure shows the table the representative curve gamma of the function h defined all by this value. Wait. Okay. So the function h defined by e of x minus e minus x minus 3x. Let's just write f of x, maybe we will use it. F of x equal ex minus e minus x minus 2x. Okay, the adjacent is the curve of the function f h. This is the curve of the function h. And this curve cuts the x-axis at 2 points of abscissa alpha and abscissa minus alpha. Show that alpha is between 1.62 and 1.63 is very easy. H of 1.62, we do calculate it. I'm going to use the calculator. Exponential of 1.62 minus exponential of minus 1.62 minus 3 times 1.62. And the answer is minus 4.8 times 10 power minus 3 is negative. Also at 1.63, equal f of h of 1.63 equal 0.017 positive, so alpha is between 1.62 and 1.63. Use gamma to show that the curve C of the function cuts the line of equation y equal x in 3 points whose abscissa are to be determined. Okay. So I'm gonna erase the board. Okay. The question is, show that the intersection between the curve of f and the line of equation y equal x is in 3 points. Okay, so we have to solve f of x equal yd. And this is number 3 part B. We are in number 3 part B. F of x equal yd. So ex minus e minus x minus 2x equal x. So ex minus e minus x minus 3x equal to 0. And we got the function h. H of x equal to 0 admits 3 solutions. Point. I'm gonna call the points A. First point of abscissa minus alpha. Ordinate minus alpha. Of course, the abscissa is equal to the ordinate because this point belongs to the line D of equation y equal x. Then point A, point E, if abscissa E of abscissa alpha, so the origin is gonna be alpha, and of course the origin of 0, 0. Okay, because it cuts this point and this point and this point. These are not the points of intersection of the curve C with the line D. They have the same abscissa because f of x equal yd, it means that h of x equal to 0. Part 4a. Calculate f of 1. f of 1, we just replace x by 1 equal e minus e power minus 1 minus 2 equal e minus e power minus 1 0.36 يعني minus 2, and the answer is 0.35. بعدين f of 2 equal e square minus e power minus 2 minus 4 equal e square minus e power minus 2 minus 4 equal 3.25. 3.25. Okay, so I'm gonna write a summary here about the exercises. F is odd, and f is always increasing from minus infinity till plus infinity. We have vertical asymptotic direction here and vertical asymptotic direction here. At 0, f prime is 0. Let's say that this f prime and this f. And f of 0 equal also 0. So at 0 we have a horizontal tangent. F of x equal yd, and the 3 points a alpha minus alpha e alpha and o 0 0. okay, بعدين عندي البوينتس 1 0.35 هيدي حسميها r 1 0.35 وعندي البوينت هاي حسميها m 2 3.25. okay, hi, the summary about what I found in this exercise. لأنه now I'm gonna erase it all and start drawing. ما تنسوا إنه هي odd كمان. okay. لحد هلا بعد ما عرفت لشو استعمل k of x صراحة. كنت فكر حتطلع في برايم equal k أو حيالله شي، بس ما طلعت لشي، مخرفة الكتاب وحياة الله. لكن هيدا خلينا نقصه للسيستم وناخده لنستعمله. This is an orthonormal system. To draw any curve, we have steps. First step, orthonormal system. Second step, the asymptotes. We don't have any asymptote. Then particular points, 0, 0. The point 0, 0. Okay, and do not forget that in this point we have a horizontal tangent because f prime is 0 at this point. Okay, بعدين f of x equal x, so I'm gonna go draw the line y of equation y equal x, 0, 0 and 1, 1. This is not an asymptote. This is a line that he asks to find the point of intersection with the curve. Okay. Points of intersection are 0, 0, the origin. A minus alpha. Alpha is between 1.62 and 1.62. This is A. So it's gonna cut the curve here at the point A. And then O, and then A prime. Not A prime, we call it E. E alpha. Only A minus alpha 1.62. This is E. كان لازم نستخدم the relative positions. As we have f of 1 0.35 on 0.35 هاي البوينت سميناها R و f of 2 3.25 هي سميناها M. Let's change the color. شو صار يا الله. يلا again. First thing I have to draw an orthonormal system. Then I have to draw the asymptotes. I don't have any asymptote. I only have the line of equation y equal x is a line that he asked about the points of intersection. بعدين عنا البوينت 0 0. هاي البوينت فيها horizontal tangent. شو عرفني فيها horizontal tangent؟ لأنه f prime مع 0 هي 0. f of x equal yd cuts at the point of A abscissa minus alpha ordinate minus alpha. Alpha is between minus 1.62 and minus 1.63. This is A, this is O, and E alpha. This is E. The point R 0.35 and the point M 3.25. We don't have any minimum, we don't have any maximum, we don't have any asymptote, we only have asymptotic direction. I need to use another color. Okay. Now when x minus infinity, when x at minus infinity, the curve is at minus infinity at vertical asymptotic direction. With x at minus infinity, the curve is at minus infinity is down, and it's a vertical asymptotic direction. It increases. ما بعرف إذا الخط واضح اللون. خليني أحط هيدا اللون أهو. When x at minus infinity, the curve is at minus infinity, it increases, passing through A. Then it goes increasing through O. Do not forget that O is an inflection point, so the curve cuts the tangent at this point. It's below, so now it's gonna be above. هون عنا horizontal tangent ما تنسوا. To the point R, then to the point E, and then it continues its direction till plus infinity. We have in this case vertical asymptotic direction. So this is the curve of the function. We can draw it in GeoGebra if you want. we have e power f of x equal e to the power x minus e to the power minus x minus 2x I think شيء. عنا اللاين y equal minus x لا y equal x هذا هو. وفي أعمل plotting للpoints إذا بدكم intersection ل this one with this one هي point A okay this one with this one هي point B وأكيد في ال O هون نسميها C إذا بدكم. وهودين هذا هو الكيرف 100% مثل ما لازم يرسم ومثل ما نحن رسمنا. طبعا اللي تعودنا أحلى يعني أحلى من الجبر. اوكي هلأ بكفي لأنه الاكسرسايز أخد اونلاين 36 minutes يعني معكم رح ياخد أكتر بكتير. يعطيكم ألف عافية وشكرا لكم.